In the transformation of stress, consider an element acted upon by stresses sigma h sigma y and the shear stresses tau h y. Now, to find through an angle theta, we will have to draw a wedge shape in which now there will be new stresses, unknown stresses. So let me make this triangle, let me name it such that it's A, B, C. So the unknown stresses are acting on the plane BC, then original stresses sigma h and tau hy sigma y are acting on the planes A, B, and AC. Now, to find the unknown stresses, we'll have to find the forces due to the stresses, and then we'll have to draw a free body diagram so that we can sum up the forces and find the formula which is required in determining the unknown stresses. Now the forces, our sigma h prime acting on the plane BC, this is the plane BC. Our normal stress sigma h prime, assuming that the plane BC its area is dA, then therefore the force will be sigma h prime dA. For my shear force F h prime y prime, so F h prime y prime will be equal to tau h prime y prime dA. Now let me name this F1, F2, F3, so on. So it will be sigma y dA. Now the plane AC, it's at an angle theta, but theta of dA. So it was a tau hy. So it will also be dA sin theta. Let me take this as F3. F3 will be sigma h dA cos theta. And this is my F4 will be tau hy dA cos theta. Now the reason I've put it in terms of F's, F1, F2, so as to simplify when I'm drawing the free body diagram. In my free body diagram, note that the tau h prime y prime, and this is my F h prime due to the normal stress sigma h prime. So they are perpendicular to each other. They're at an angle of 90 degrees to each other. So I'll make a y-x axis, which is the y-axis is parallel to f h prime y prime, and the x-axis is parallel to the f h prime. My summation of forces will be due to f h prime and f h prime y prime. Both should add up to 0. So now the components. This will be F3, F4, this is F2, and this is F1. So the components y prime, h prime. So the components of F1 in addition to that angle, it will be something like this, and F2 similarly is that way. For F4 and so now I'll first do my summation of forces with regard to the h prime, the x-axis. So now I have my summation. So my fh prime, remember my fh prime is acting on that direction, is equals this. For example, my f1 will act in the opposite direction, so it will be f1 sin theta. F2 will be cos theta. F3 will still be cos theta, and F4 will be sin theta. Now what I want to do is I want now to substitute my values, my what fx prime was and what the others were. So my fx prime was sigma x prime dA. My f1 was sigma y, my sigma y dA sine theta. So we have to sine theta, so sine squared theta. F2 is tau xy sine theta cos theta dA. My F3 will be sigma x was sigma x cos squared theta dA, and my tau xy, my F4 is tau xy sine theta cos theta dA. Now the d's are constant, so I'll just cancel them so that I have sigma x prime is equals to, so what I'm then going to do, I'll put sigma x cos squared theta plus sigma y sine squared theta plus 2 tau xy sine theta cos theta. Now using trigonometric identities, I have that cos squared theta is equals to 1 plus cos 2 theta, and sine squared theta is equals to 1 minus cos 2 theta over 2. Remember that 2 sine theta cos theta is equals to sine 2 theta. So now, substituting this, you should get something, there'll be a 1 plus cos 2 theta for the sigma x, and there'll be a 1 minus cos 2 theta. This will be tau xy sine 2 theta. Now, what then I want to do is put the, when I open the brackets, I'll have some like sigma x plus sigma y over 2 plus sigma x minus sigma y over 2 cos 2 theta plus tau xy sine 2 theta. And that's the expression for the unknown stress. Now, for summation in with regard to the y-axis. Now the y-axis, in which, remember, I'm taking the datum point as the plane in which we have unknown stresses. So we'll have our first force fx prime y prime, f1 sine theta, f2 moving in the upward direction, so f2 sine theta. We have f4 will be f4 cos theta, so f4 cos theta, but moving in the downward direction, the component. And I have f3 is also moving in the upward direction, so f3 the sine theta. Now what I'll then do is I'll substitute the values, so this should add up to 0. So now my fx prime y prime is the same as tau x prime y prime dA. My f1 was sigma y dA, so sigma y dA sine squared theta. My f2 it will be tau xy dA sine squared theta. My f4 was tau xy dA minus tau xy dA cos squared theta, and I have plus sigma y dA cos theta. So for this one was sine theta. My f1, this was cos theta. Therefore, the sigma y will have to change to cos theta sine theta. So cos theta. Now, similarly to the first one, the dAs are alike, so I cancel them. So now I have my expression as tau x prime y prime minus sigma y cos theta sine theta plus my f4 my f4 tau xy cos square theta minus sine square theta plus sigma x. This was sigma x cos theta sine theta. Now from the trigonometric identities, remember that cos square theta minus sine square theta, and also sine theta cos theta will be equal to sine 2 theta over 2. Now in my equation, I have both. So tau x prime y prime I make so this is a plus. So taking it to the other side. This was a minus. So taking it to the other side, I have negative sigma x minus sigma y cos theta sine theta plus tau xy cos 2 theta. My last thing is to substitute the cos theta sine theta with the trig, which is sine 2 theta over 2, so it becomes negative sigma x minus sigma y over 2 sine 2 theta plus tau xy cos 2 theta. So now this is the identity due to the shear. So we have found the identity of the unknown shear stress and the identity of the normal stress, which we found as. Thank you for watching.